This is section 8.5, part 1, and we're going to look at the sum and difference formulas. So when you look at the sum and difference formulas, you're going to find that there is a blue box on the page that contains all of the ones that will be on a formula sheet for the next test and the final exam. So if we look through them, we have the addition of alpha and beta for cosine. So cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And we also have the difference of the two angles with cosine. Cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. Then we have the addition of angles with sine. So sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Or the difference, sine alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. And then finally we have tangent, the sum of tangent. We have tangent alpha plus beta equals tangent alpha plus tangent beta, all of that over 1 minus tangent alpha tangent beta. And the difference, tangent alpha minus beta equals tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Now these sum and difference formulas will allow us to find values as long as they are on the unit circle and that we know them. It allows us to find values that we couldn't find before. So for instance, if we look at this next example, it says use the sum or difference formulas to find the exact value of the trig functions. I do not know what sine of 5 pi over 12 is, but I do know that if I add or subtract two of the known unit circle values, I will be able to figure out what the answer to this is. So just as a reminder, those unit circle values are written up on the page, and what I did was I took all the values all the way around the unit circle and I placed them up here in degrees. So for this example, the first thing I would do is I would convert 5 pi over 12 to degrees. Okay, so to do that, I do 5 pi over 12 times 180 degrees over pi. The pi's will cancel out, so let me go ahead and do that. And 12 goes into 18 once, and 12 goes into 65 times. So now we're left with 5 times 15. So we get 75 degrees here over 1. So actually what I'm looking for is sine of 75 degrees. So my next step is to figure out what two angles add or subtract to give me 75. So when I look at this, I need two angles. And if your angle ends in a 5, usually it has something to do with 45. So if I use 45 and I subtract 45 from 75, I will see the other angle will be 30 degrees. And you can check it quickly by adding these two together. 45 plus 30 will give me 75. So I'm going to rewrite sine of 75 using those two angles so I can use the sum formula. So I'm going to put 45 plus 30 degrees. Now I have to use the formula. So the sine alpha plus beta formula, I'm using the addition formula, equals sine alpha cosine beta plus cosine alpha sine beta. And now I'm going to determine what is alpha, what is beta. So alpha is your first angle, so in my case it's 45 degrees, and beta is going to be 30 degrees. So if I use this information and I plug everything in, I get sine of 45 degrees times cosine of 30 degrees plus cosine of 45 degrees times sine of 30 degrees. And now I'm going to place in values. So sine of 45 degrees is radical 2 over 2 times cosine of 30 degrees, which is radical 3 over 2, plus cosine of 45 degrees, which is radical 2 over 2, times sine of 30 degrees, which is 1/2. Now I'm going to multiply these together. So if I multiply this together, I get square root of 6 over 4 plus square root of 2 over 4. And I'm going to give you a warning. This answer would be fine, but on the review sheets and on the tests and just the way it's written up, they expect you to take out a GCF. So basically we're looking for what's common to both of these. And we notice that we have a square root of 2 in both of the terms, and we also have 4 in the denominator. So if I take out the square root of 2 over 4, what I'm left with is square root of 3 plus 1. So if you see the answer like this, that is how they got it, is by taking out the GCF. Okay, so this next question, and I seem to have forgotten to erase everything, so let me erase this really quick. It's asking you to do a bunch of stuff. It's asking you to find cosine theta given that sine theta equals 5 over 6 and theta is in quadrant 2, and it's also asking you to find part B, part C, and part D. So let's go ahead and look at that together. Let's do part A first. Part A is asking us to find cosine theta. Now, if I know sine theta is 5 over 6, that means that the opposite side has to be 5 and the hypotenuse has to be 6, because sine is opposite over hypotenuse. So to find cosine, I'm going to have to draw up a triangle. I'm going to go ahead and put theta here. The opposite side is 5, the hypotenuse is 6. I have to find that missing value to find the adjacent side. So I use Pythagorean theorem, and I come up with 5 squared plus x squared equals 6 squared. I get 25 plus x squared equals 36. X squared equals 11. X equals square root 11. So I'm going to go ahead and put that in there. So now I have adjacent side, opposite side, and I have the hypotenuse. So I'm going to erase this just so I have room. So cosine theta is adjacent over hypotenuse. So the adjacent side is radical 11 over the hypotenuse, which is 6. So let's look at part B. Part B asks us to find the addition of theta plus pi over 6. So once again, I have to use the addition formula of angles for sine. So remember, that was sine alpha cosine beta plus cosine alpha sine beta. And now I'm going to put everything in place. So remember, alpha is theta and beta is pi over 6 or 30 degrees. So if I plug everything in, I get sine theta times cosine of pi over 6 plus cosine theta times sine of pi over 6. Now I have to plug in values. And by the way, before I continue on, I did make a slight mistake with part A. The question tells us we're in quadrant 2. In quadrant 2, sine is positive and cosine is negative, and so is tangent. Okay, so being that said, I need to put a negative sign on part A, because the answer, and let me just make this more clear, is negative radical 11 over 6. And the reason why it's negative again is because we're in quadrant 2. So now I'm going to continue on to B. So I know I pedaled back to A, but let's go ahead and plug in values. So sine theta is positive 5/6 times cosine of 30 degrees, and cosine of 30 degrees is radical 3 over 2, plus cosine theta is negative radical 11 over 6, because I'm in quadrant 2, times sine of 30 degrees, which is 1/2. Okay. So before I continue on, like I said, you may have to take out the GCF. So I'm looking for what's common in both. I see that my denominator both have 6 times 2, which is 12. And in the numerator, there isn't anything common. So I'm going to pull out 12. So I have 1/12 times. And then I have left in the first term 5 radical 3. And then in the next term, I have negative radical 11 times 1, which is just negative radical 11. So here is the answer for part B. Okay, I'm going to go ahead and do part C. But in order for me to have room, what I'm going to do is just erase what I wrote down. So if you don't have that copied down quite yet, go ahead and stop the video to get caught up and then restart it. So part C says I need cosine of theta minus pi over 3. So once again, I need the formula that has the difference of the two for cosine. So cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. And guys, these problems aren't really too bad, but I would double check them to make sure I wrote down the right thing. So that's what I'm doing right now, is just doing a quick double check, and I see that it's okay. And now I'm going to label things. So alpha is theta, and beta is pi over 3, which is equivalent to 30 degrees. So if I plug that in, I get cosine theta times cosine of pi over 3 plus sine theta times sine of pi over 3. Okay, so cosine theta is negative radical 11 over 6. And I found that by taking adjacent side over the hypotenuse. And remember, we're in quadrant 2. That's why cosine's negative. And then I'm going to multiply it by cosine of 60 degrees, which is 1/2. Plus sine is positive 5 over 6 times sine of 60 degrees, which is radical 3 over 2. Now I'm going to look for commonalities. The denominator both have 6 times 2, which is 12, so I know I can take that out as a GCF. So if I take 1/12 out, I have negative radical 11 times 1, which is just negative radical 11, plus 5 times the square root of 3. So this is my answer with the GCF taken out. Okay, so we have C done. Now I want to do D. D is asking me to find tangent of theta plus pi over 4. So once again, I am going to erase this, so pause it if you need to, and then start it when you're ready to go. All right, so tangent. I'm looking for the sum of theta plus pi over 4. So if I look up at the sum and difference formulas, I'm looking for the addition one. So I have tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Okay, and then I'm going to double check that just to make sure I wrote down everything correctly. And I'm good to go. So alpha in this case is theta, and beta is pi over 4, which is equivalent to 45 degrees. So I'm looking for tangent theta plus tangent at pi over 4. And then I have 1 minus tangent theta times tangent at pi over 4 in the denominator there. Okay, so the next thing I have to do is substitute in. Remember, tangent is opposite over adjacent. So tangent theta equals opposite, which is 5, over the adjacent side, which is radical 11. And remember, it's negative because we're in quadrant 2. And if I rationalize that, I get negative 5 radical 11 over 11. So when I plug that in, I get negative 5 radical 11 over 11 plus tangent of 45, which is 1, all over 1 minus negative 5 radical 11 over 11 times 1. So I have to find a common denominator, definitely. So 11 does the trick. So I get negative 5 radical 11 plus 11 over 11. And in the denominator I get 1 plus 5 radical 11 over 11. And I got that by multiplying 1 times negative 5 radical 11 over 11, and then multiplying that negative by negative to get a positive. Okay, so to simplify this down, I get negative 5 radical 11 plus 11 all over 11 in the numerator. And in the denominator, I have 11 over 11 plus 5 radical 11 over 11. So we got to simplify down that denominator. So I have 11 plus 5 radical 11 over 11 in the denominator, and negative 5 radical 11 plus 11 in the numerator over 11. Because this is a complex fraction, I'm going to take the reciprocal of the denominator and see if I can't cancel anything out. So that becomes 11 over 11 plus 5 radical 11. The 11s will cancel each other out, and that's all I can cancel out, because this term here in the, whoops, I don't want to do that. That term here in the numerator, this is a binomial, and so is this. So when you have binomials, they have to be exactly the same. So my answer is going to be negative 5 radical 11 plus 11 over 5 radical 11 plus 11. And like I said, these are not like terms because the 5 in the numerator is negative and the 5 in the denominator is positive. So there's your answer for that. So that is going to be the end of the first part of the section. There will be another video.